In this video, I want to show you how to use Excel to perform the cash flow analysis in Chapter 11, and especially on about the risk analysis part. So how do we use Excel to perform the sensitivity analysis and scenario analysis to estimate cash flows and actually the NPVs and IRRs under different conditions. So the template, you see the same file that I uploaded on D2L. You see that you have the basic information about this mini case, and all the key inputs are here, and for example, cost of capital is 10%. Okay, and then starting from part B, this is actually consistent with your lecture slides. This is actually just showing you how to get those numbers or perform those calculations in Excel. So for example, this is according to the MACRS depreciation schedule table in your book or on your slides. If you click on this, you see depreciation expense for the first year is this percentage number multiplied by the $240,000 depreciation base. Now you notice that all these results are calculated, and when I have the depreciation basis, I don't just type in $240,000. I tell Excel this equals to my original inputs of $240,000, which is from the three numbers overall here. Okay, and also like my sales, $250,000. I don't just type in $250,000. Instead, I tell Excel that this is based on 1250 multiplied by the 200, and the cost 125 is based on 200. Actually 1250 multiplied by 100. Okay, so it's important that all these numbers, all these results are calculated step by step by your major key inputs. Okay, and by the way, this, as you see, 200, you don't just type in 200, you actually want to go back to the key inputs and hey, D44, that's where the 200 is coming from. Okay, so why are we doing this? Why don't we just type in the numbers? It is actually quite important here. By the end of this video, maybe you will get the idea. Okay, I'll explain that. So, if you follow the lecture slides, you understand how we got these numbers, and you understand the net cash flows is estimated, operating cash flows, and then we have initial investment together $270,000, recovery of the salvage value, recovery of the net working operating capital. So this is the list, I'll say the timeline. Again, consistent with what you see from the lecture slides. Once you have the timeline ready, you can go ahead and calculate NPV. If I click on this cell, you see NPV calculation equals to NPV, then D42 is the cost of capital, F 111, so it's actually these numbers together, and then you add the negative $270,000. So actually, let me just do it one more time here just to show you. Okay, equals to NPV, and I go ahead, click on the 10%, and then I include all the cash flows in the future. I'll say the future estimated free cash flows, and then I add my initial cash flow, which is actually a negative number, so I'm actually subtracting the $270,000. You don't want this to shown as percentage, you just want to show it as dollar. Common mistake would be you say okay equals to NPV, and 10% cost of capital, that's fine. And by the way, you see I go back to refer to cell D42 instead of typing 10%. Now, common mistake, I put everything all together. This number is not correct. Okay, so you actually want to include future cash flows from year 1 in your NPV calculation, and then you want to add the initial cash flow amount at time 0. For the IRR, quite simple. That's it. Okay. If you want to see more decimal, just simply try to have more decimals. For the modified IRR, I have all these cash flows. Now I tell Excel that my discount rate is the cost of capital 10%, and the reinvestment rate is also the same 10%. Remember, according to the lecture slides, to calculate MIRR, we assume that future cash flows are reinvested at the cost of capital, while IRR assumes that future cash flows are reinvested at IRR. Now 18%. Okay, so once you have the timeline ready, Excel can perform NPV, IRR, MIR calculations really fast. Okay, now, like I said, what I'm more interested to explain in this video is sensitivity analysis. How do we do the risk analysis? How do we do the sensitivity analysis? How do we answer the what if question? What if VAC is not 10% as we assume? What if it's only 7%? What if it's actually 11.5% or 13%? What if you're not going to sell 1250? Instead, you can only sell 875. What if you recover 32,500 as salvage value instead of 25,000? Okay, so these are all what if questions. So you want to see how your NPV result is sensitive. How sensitive is it to the change of your VAC, or the change of your unit sold, or the change of your salvage value assumption? To show you how to get these results without going back and calculate time after time, I'll show you the trick from Excel. Okay, remember, you want to see how NPV result changes. Your initial or original NPV result is here, and that result is calculated based on all your previous analysis, and you only need to do that round of analysis one time. Okay, now you select this two columns together, and you click on data, what if analysis, data table. You want to change the column inputs, because this column of numbers or inputs, any of these numbers are supposed to replace your initial or original input of the VAC, which is the 10%. Okay, and ta-da, your NPV results are updated. And $88,010, that's based on 10%. This is our original assumption. So your NPV result is the same as your original amount. But any change in VAC, your NPV will change, right? So now maybe you have the idea why we want to refer to the key inputs every time we try to perform a calculation here, because this way all the results are strictly based on your key inputs. Okay, so this is like a chain reaction. Then if one number changes, like cost of capital changes from 10% to 7%, your result will be automatically updated. Okay, if you type in this case, if you type in 10% here, Okay, I still get the same result because your cost of capital was 10%, but now you see your numbers will not change. Okay, but again, when I go back and instead of typing a value, I type in, or say I go back to the cell. You see the changes. Okay, one more practice. What if my units sold change by 30%, positive or negative? Okay, again, my NPV result is calculated from here. Okay, and then in this 2-column table, what if my unit sold changes from 1250 to any of these numbers in this column? Your result change. When it's 1250, you get 88,010, which is the same as original amount, but any change in units sold will bring a change in NPV. Okay, so now you pretty much know what to do. Equals to NPV, 2-column table, what if analysis, change the column input to the salvage value of 25,000. Right? Then you can also pull these results together. So 30% change in WACC give you a different NPV. 15% change in units sold give you a different number, right? And you can also put them in this one graph, which kind of shows you, okay, look at the slope. Let's say 20% change in the units sold. Because of the steep slope of this line, this has a big impact on your NPV. Now 20% change in your salvage value not really brings big change in your NPV. So based on the slope, you kind of can tell which variable is more important, or say your NPV result is more sensitive to which variable, and also in what direction. Like WACC, higher WACC actually lower NPV, higher units sold, higher NPV. Okay, so putting the results in the graph give you quick idea about how your variable changes affect your NPV changes. The change of NPV, which is the essence of sensitivity analysis. How sensitive is your NPV to the change of your assumptions in any of these variables? Next, I want to explain the scenario analysis in Excel. So, as explained on the lecture slides, in the scenario analysis, we look at different scenarios. For example, the best case here, when you sell a lot of units, and for each unit the price is also high. Worst case, you don't sell much, the price is also low. So how do we get these results? In Excel, you can also do scenario manager. The templates already include all these scenarios described. So to explain, I'll delete all these and we'll start from scratch. Okay, so first, let's say what if analysis, scenario manager, add scenarios. Our best case scenario is according to this, right? So what do we want to change? We want to change unit sales and unit price. So let's go back to the inputs, the key inputs. We want to change these two. Okay. What do we want to change to? In the best case scenario, you sell 1600 at $250, $240 each. Okay, we add another scenario, which is the base scenario, base case. We are also looking at the same two sales, unit sold and sales price. That's the base value, so we'll leave them unchanged. What about the worst case? In the worst case, you sell only 900 and the sale price will be low. And of course, you can add some other scenarios like slightly better case, and then you just have to change the numbers, have a new different set of numbers. But in this case, we'll just explain the three scenario example, and then we will just look at the summary. Okay, so in each of those three scenarios, what would be your results? The first thing you may want to look at is the scenario summary, and what result are you looking at? We want to look at NPV and IRR. So it's doing this calculation. Now it's showing you that in the base case, your NPV is 88,000, your IRR is 24%. In the best case, you are happy with much higher NPV and a much higher IRR. In the worst case, unfortunately, your NPV will be negative and your IRR will be very low. So this is a one-step calculation about NPV and IRR under different scenarios. And like I said, you can add more scenarios just to see how exactly your results can be different. You can also look at the result in a different way. So if you select scenario pivot table report, you get essentially the same result but presented in different way. So this column is actually about the NPV, this column is about the IRR. NPV under different cases, IRR under different cases. Again, like I said, same result, different way of presenting it. So as long as you master the scenario manager in Excel, you can have Excel to show you to present your results under different scenarios. Last, I just want to mention the Monte Carlo simulation. Excel actually is not the best tool to perform a simulation analysis. So I'll just briefly talk about this separate worksheet you see, and it kind of explain what exactly are they doing here. So what you see in this worksheet, so far they're still calculating NPV and IRR based on this timeline, which is based on the cash flow analysis that you have already seen in the previous worksheet or on your slides. But the difference here is, instead of using 1250 or 200, here they are assuming the sales price and the units sold and sales price are random variables that satisfy a normal distribution. That, for example, the units sold, instead of being only 1250, it could be any number, and it could be any number that's based on this normal distribution that has a mean of 1250 and a standard deviation of 200. So remember, for the simulation, you're going to do it 1,000 times. In this example here, you have 100 times, and you have 100 times of the units sold, all different numbers every time. and overall all these numbers of your units sold together, they should have a mean, or say expected value, of 1250 and a standard deviation of 200. Same idea with the sales price. Instead of being one number, 200, it could be any number, but we assume it could be any number based on this normal distribution that has a mean value of 200, or say expected value of 200 and a standard deviation of 30. So again, if you see in Excel, you do 100 times all 100 observation together, they have a mean of 200 and a standard deviation of 30. Okay, so essentially what they try to do here in Excel for the simulation analysis is that it's a sensitivity analysis. You do the same calculation over and over again, in this case like 100 times. Okay, you calculate the NPV, you repeat the process, you calculate NPV, and then you summarize the NPV. You find out, okay, the mean value of all the NPV results you get from all 100 times of trial, about $84,000. Minimum is $160,000 negative. Okay, median, standard deviation, max value. So you look at the whole distribution about all the NPV results you get under all 100 from all 100 times of trials. Okay, another thing I want to say is, in this case, the way that Excel handles it is by setting a number here and then doing it 100 times. As you see, Excel is randomly selecting your unit sold and sales price, okay, all together for like 100 times. And this then is also a what if analysis. Now you just want to change this column, you just want to use the numbers from this column to replace this number, and your results, your NPV result will automatically be updated. So by using this column, you are actually getting a new set of units sold and sales price, then your NPV will be updated. Okay, and then based on all different NPV results from all different times of trial, you summarize, you kind of get the idea about how your overall NPV can be. What is the probability of NPV being positive, or say how likely would you end up with a negative NPV? In this case, about 11%. So like I said, I don't think Excel is the best tool to perform the simulation analysis. We have better softwares, but this is just to show you that if you want to use Excel to perform the simulation analysis, basic idea is you try to do it, you repeat this process for many times, and you look at all the different results of NPV. You try to come up with a probability distribution to understand how your NPV will change.